I want to discuss, just for the sake of illustration, a little example, a little exercise which shows the computation of just the few things that I discussed a few minutes in our earlier modules. Number one, I want to remind you that I have mentioned that I am using mainly the book Fluid Mechanics, written by Yunus Sengel and John Simbala. So this exercise and some of the images that I am taking have been picked up from the book, and the equations or the images or their references can be seen in that book. So this is just for a reminder, otherwise that has already been mentioned. And obviously this example, this exercise that I am discussing here is just to illustrate things, but we shall be handing on to you assignments and exercises and what we call as homework. Let's first go through the question or the example that has been posed that we want to attack here or solve here. And we are considering a steady two-dimensional velocity field. That means it's not a three-dimensional motion, so we don't see the z component or related to it the k unit vector. A steady incompressible two-dimensional velocity field is given by the velocity as depicted 0.5 plus 0.8 times x in the x direction plus 1.5 minus 0.8 times y in the y direction, where x and y coordinates are in meters. So the unit distances are taken in meters and the magnitude of the velocity is in meters per second. A stagnation point is defined as a point in the flow field where the velocity is zero. So that's defined to be as a stagnation point. The fluid is stagnating at that point. Determine, so that was the situation that was given to us. Now the question, determine if there are any stagnation point in the flow field. If so, where? So we have to give the point where there is a stagnation point, if it exists. And secondly, they want us to sketch the velocity vector at several locations in the domain between x equals minus 2 to y equals 2 meters, and also for y the variation is from 0 to 5 meters. So you can see, and then qualitatively describe the flow field. So 3 questions in one question. We need to find stagnation point, we need to find the velocity vector at several locations, and also then we need to describe the general flow field, and we need to graph it also. Now we come to solution. So obviously it's so important that first we understand the flow field situation. And for locations of stagnation points, it has been defined, the definition has been given that it has to be, the velocity has to be zero at that point. So that means the x component has to be zero, y component has to be zero. Why? You see, as we are familiar, the velocity v, if there are two components, is equal to square root of u square plus v square, where v is the component in the y direction and capital V is the velocity as a whole. These are square terms. This can only be zero if each one of them is separately zero. So therefore, u has to be 0 and y has to be 0. Both of them has to be 0. So if I substitute u equal to 0, then we will obtain the x coordinate from there, and the x coordinate turns out to be as minus 0.625 meters. It has been given that all these measurements are in meters and the velocity is in meters per second. And therefore, in a similar way, we have to put the v component also equal to 0. When we do that, we see that the result of y is 1.875 meters. So, we have a non-zero answer. And therefore, yes, the stagnation point exists, and the stagnation point is located at x equal to minus 0.625 meters, y equal to 1.875 meters. Then we come to the second part. The x and y components of velocity are calculated for several locations. So when we plot a graph, so obviously we give different values to x and y, and we will have all different values of v. So in this way, we can have several points for which the points can be plotted on a graph paper. And then those dots that we place, the points that we display, can be connected. And of course, we have to take a very large number of points, not 1 or 2 or 3. We need to have quite a few of them. Some of the points that they have mentioned, how to take it is, for example, at the point x equal to 2 meters, y will be 3. So this gives us 1 point. And at that place, the velocity will be u, it can be calculated. And similarly, several such points can be collected, and then they can be plotted.